So now let's start to uh, so here what we did initially was we created the RNN by ourselves. Now what we'll do is we'll try to convert this tutorial into using the defined RNN which is being provided by top pytorch. So here we are making the changes. We are removing the I2H and I2O by NN RNN. So here it's saying that it needs input size, expected number of features, and number of features in our X is 57. So we can use the same thing. Hidden size is the hidden size. So right now we are just putting input size and the hidden size. Number layers, let the default be 1. Non-linearity, let the default be 10H. Maybe later on we'll do some experiment to see how the ReLU will work. First batch, let's make it true, or let's just first see. Let's say if the batch size is, batch first is by default, if it's false, uh, let's say if it's false right now, let's see how it affects the things. So output, so let's have the softmax because we want to run the softmax on the output. Okay, and bidirectional is also false, dropout is also right now false. We'll also do some experiment on dropout, so let's just use that as well. So now here we have to define the input. Now it's the tricky part, so how to make the changes. So we are passing input and hidden. Now we may not need to pass hidden. So the question is how to change this. So we may have to uh, write our, because here now we'll just pass the input and only okay, we are passing h0. So here we can assume that we are passing h0, but h0 is a solid default zeros here. So let's see how, and the output is okay. uh, 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 uh. So let's see how we can make the changes. So this is the shape. So here what we are doing is we are copying the plain method which we used for the raw RN implementation, and we'll try to uh, use now our PyTorch RN model. Yeah. So here also let's also define. So this maybe we can define. Are we using RN somewhere else? RN here. We are not using RN. Okay, we are using this and so saving it. Uh, so this needs to be changed because now RN is different. So how to do it? We just uh, so here we have the fit method which is giving us all losses, but that is also the RN. So the way we can do is we can have we can define on top save data. We can save data, and here we can pass what kind of so let's try to make some modifications to this function, to this class, to support both the PyTorch RN and our own created. So let's just make some changes. We don't need, let's just see that we don't need we just need to call the fit and even save. We should move up, put RN type. So by this we don't need we need all losses. So resource here, and for now let's have the RNN as common. So let's just see the copy, control C, and to return anything, and just in save only we can do the save. Okay, so we are saving here, and based on the RNN type we'll create one more. It should create one more folder here and should put the losses and the RNN there. So I think this looks good. So one thing that we need to make changes is, first based on the type we have to get a new RNN. So let's see, this is our default, and now let's see if RNN type equals pytoch, which is in our case. So let's create RNN is equals to torch RNN from model copy related from model pytoch. I think this should work now. And hidden, we have to pass hidden, and we have to pass this. So this is should we have to create the same RNN, and now we have to create our own train. So we'll click on train torch and use torch. So here we are creating the hidden layer. We are doing this. Hidden will right now have, and I think here also based on the we should also join path, then dot join path RNN type. So now interesting thing is, because now RNN is handling itself, so ideally we should not do this. We should directly get so ideally this should get commented out, and directly we should use output and new hidden is equals to, although we don't need, so let's put it this, output is equals to RNN, and we just need to pass the complete line tensor and our hidden. So I think that should work, and we are then running the loss on that. So we need to make sure that we need to spend some time on the dimension other thing, but let's see. And then finally we are doing this, so we also need to see if we need to do this, or we can do it something, but let's see. Okay, and finally what we have to do is, here we have to make changes, which is if RNN type, or we can say it's true also, but let's say torch, then otherwise else if use train torch. So now let's run it and see how it's working. Finally, we should change this as well. Why we even calculate this with this 2L's. Let's run it again. So it's going inside. Let's see what. Let's go inside. So input size is 57. The hidden size is 128, and the output size is 19. But the interesting thing is here we have not passed input size. So ideally we will need this layer, which will take. Ideally it should just take. Now what should we do here? Finally we are getting a hidden layer, and ideally we should just run. We should. Now it should not be input size plus hidden size. Ideally it should be just a hidden size, because we'll do it on output of hidden size. And finally it will give an output size. Run the softness. So here also, I think on the output and hidden we'll need some way. So output is, I think, the final hidden size. So what we have to do is hidden sort of, we can say hidden n, because it's hidden n, and then output, actually output is here we are passing is hidden n, hidden hidden n, and then output. So we have to see the dimensions, but I think this is what we need to do here. So let's just run it again. Goes inside. Let's just go inside. So if we see, that's what we are doing. We are passing input size, which is the number of expected features, which is 57. The hidden size is, we are saying, 128. So here there is no mention of output. So right now we pass batch size false and dropout 0. We are creating our output layer, which is a linear layer from the hidden size to get the output size. Yeah, and then we are applying the softness. Then we are calculating this learning rate going down. So let's go into the fit method. It got a random value. Let's see what the value is. Category German, line Herman. This got category tensor, which is of size 1, which is, its value is 5, and the line tensor, now that's interesting. So line tensor value is 6 1 57. So the way we can consider this is 6 is our sequence size. The 6 is the sequence size. 1 we can say is a batch, and 57 is what our input size is. So let's see how it works. So it goes into training, and let's see what it has written. So hidden is 1 1 128. So here if I see input, it should be number layers, number direction, which is 1, batch 1, and hidden size is 128. So let's see. So we are doing grad 0. So here it has created the locations for saving our hidden and output values. So id hidden should not be there, we should just do it for the output, but here okay, so we'll see. So let's just try to go inside this. Yeah, so now here's the interesting thing. So our self is so our input is 6 1 70 57, and the input is, and the hidden is 1 1 28. So what they are saying is, and now let's see if it works, or it throws any error. Okay, so now let's see what we have got. So what they are saying is we'll get two outputs, HN, I think that's what we should use actually, an output containing the output of the last insert. Okay, yeah. So what they are saying is output is contains the output of shape, sequence length, batch, num direction to hidden size. I think what we are looking for is this. We want 1 1 and the batch size and the hidden size, and then we need to pass here. So here it should be hidden new. I think we also need to check so let's also check and dot linear, what shapes it expects. So we see in feature size of the input sample, which we have given here, output feature size of output file input. Now it contains n. Okay, input contains n star means any number administrative dimensions, and output will be n star output dimension. So here what to do is, if we are here, I think if our hidden and new will be 1 1 1 128, so I expect my output to be 1 1 and 19. Okay, and then softmax log softmax pytoch so here I think we need to reduce the size. If we can do it, reduce the size. So how we can reduce the size? Okay, we have to reduce dimension. Okay, it will reduce all. So if we try this, so let's say if let's say x is dot zeros 1 1 128, and what is my x dot size shape. Now if I do y is equals to dot squeeze x. Now if I do y dot shape, yeah, it has reduced. We just need to reduce 1. How we can do it? it will squeeze only in that direction. That's sort of hack, but if I do z is equals to torch dot squeeze x in dimension 0, what it will do? Oh, that worked. Oh, that's sort of hack, although uh, but I think they should work for us, so maybe we just squeeze hidden. So hidden new is equals to hidden new torch dot squeeze hidden new 0. So now it should be, we expect this to be 1 comma 128, and this should work now. Let's see, let's run it again. So my hidden one is of size 6 1 128. My hidden new is of size 1 com 1 1 128. So if I do this now, my hidden new is 1 comma 128. If I now run out is my 1 1 119. Perfect. Now I can run sort max on dimension 1. So my output is now that value, and now let's just perfect. Oh, error. There is an error because we are just returning the output, so we don't need to do this. There is only single value. Let's run it again now. Just wait for this. Perfect, it has worked now. So it has created an output 119, and I think that's how it in criterion method, that's what it asks for. Let's see, it has calculated. Yes, it has calculated a loss which is something 2.9, which is in somewhat range of what we have seen earlier. Now let's see if it packs. So also let's also save this our loss, so that we see, let's see the graph of how it's working. So let's put it in the loss, let's put it in the output graph, output charts dot join path loss graph. Okay, now let's run again. Let's see, it is created. Perfect. Pytoch, we have the loss graph now. Yeah, so somehow my Visual Studio crashed. So here if we see what it is doing is, so this is same where we have the output layer. We are doing stack backward 10h. Okay, add backward. So if we compare this with the one we created earlier. We have deleted those, so don't worry. We'll create that again to see the difference between how it's they have created and how we created. Yeah, so let's just comment this so that we can run this. We'll come back again on how it has created the execution graph. So let's see what are the values it has. So if I do, so we saw that earlier in our previous one, if I did list of length of island or parameters. Now it's showing me 6. Okay. So what are those? He is let's come back to this again. Here I think maybe we can use some other optimizer so that we don't need to do this ourselves. But let's do it for now. Let's just run it. Let's just stop at where it will save the data. So now let's see. Let's try to save the data. Oh, okay. That's strange. It has not even created itself. Okay, so let me just create. That's a problem. So let me just create the folder myself. Let's just run small so that we can test it again, and then we'll run it again. Now let's save both, so let's just run